So we're going to build on the factoring that we started to do in the last class period. When you look, and you've seen this form of a quadratic equation before, this standard form, they call it expanded form here, it's also called general form, and we're only going to be factoring ones where the leading coefficient of the x squared is already 1, or we can get it to be 1 before we actually factor. Factored form looks like this. So, and you saw that yesterday, where the factored form on the one in the notes ended up being x plus 4 times x minus 5. Now, sometimes you will have a number other than 1 out in front of these parentheses, so it might be 2 times x plus 4 times x minus 5. And then we didn't have the y equals, but we could have put that in there, y equals. So this is sort of building on what you saw yesterday. The thing that you're going to do is this. If you graph this equation, what you're really interested in quite often is where the parabola crosses the x-axis. Those are the zeros. Those are the solutions. Those are the x-intercepts. They're the roots. We use all of those words. And the reason we're able to solve these this way is because any point on the x-axis has a y value of 0. So this point might be, say, the point -3, this point might be the point 4, but when I'm wanting to find those points on the x-axis, it's when y is 0. So you'll see in the homework today that we end up taking the y and ultimately we replace it with a 0 instead. Not right away all the time, but ultimately that's going to happen. And I'll talk about the zero product property a little bit as we go. So here I already have this in factored form, x minus 9 times 3x plus 4, and the y over here has already been replaced with a 0. The zero product property basically says this. If I multiply two things together and get an answer of 0, the only way that could happen is if one of the things was 0 to begin with. So this would give me 0 if x minus 9 equaled 0 to begin with, or 3x plus 4 could also have equaled 0. So what ends up happening is I set each of the factors equal to 0, and then I can solve that equation. I would add 9 to both sides here. So one of my zeros is x equals positive 9, and I didn't need to write that plus in front of it. Here I would subtract 4 from both sides and get 3x equals negative 4. Then when I divided both sides by 3, I would have ended up with x equals negative 1 and 1/3. So when I graph the parabola y equals x minus 9 times 3x plus 4, that parabola is going to cross the x-axis at positive 9 and at negative 1 and 1/3. That's what this is telling me. Here, this is actually not a quadratic equation, because if I multiplied this out, I would have 3 x's multiplied together at some point, and I would end up with x cubed. So not everything's a quadratic equation. The ones you actually have to factor are. Well, I'm multiplying 3 things together to get an answer of 0. The only way that would work is if 4x equaled 0 to begin with, if x plus 6 equaled 0, or 4x minus 9 could also have equaled 0. To solve for x on the first one, I just divide both sides by 4, and one of my zeros is when x equals 0. The second one, I would subtract 6 from both sides, and yes, all of this is required work. Well, actually, I'll show you the required work in a minute. So x equals negative 6. And here, the first thing I would do would be to add 9 to both sides to get 4x equals 9. Then when I divide by 4, this is x equals 2 and 1/2. So here's what happens. If I graph this parabola, and you're not expected to graph these, but this would be a parabola because if I multiply these together, I'd get an x squared. This would cross the x-axis. Okay, that's a really horrible looking parabola, but it would cross the x-axis at positive 9 and at negative 1 and 1/3. This, being a cubic function, has that extra wiggle in it that I talked about before. It's going to cross the x-axis at negative 6, come back down through at 0, and then go back up at positive 2.5. So negative 6, 0, and 2.5. That's where it's going to cross the x-axis. You're going to start with this thing not being in factored form. The first thing you want to do is get the y on one side by itself, which it is, in this case. The second thing is to look for a common factor. So first, y by itself. Second, check for a common factor. What I mean by that is if I look at the x squared and the x, they both have an x in them. So if I factor an x out of both of them, factor an x out of an x squared and I get an x, factor an x out of a minus 2x and I get a minus 2. I'm just reversing the distributive property. Since the distributive property is multiplication, when I pull the number out in front, I have to divide each of the terms to see what's left. And because we want to solve for when y equals 0 at this point, I'm going to replace y with 0. Now it just becomes a solving. X equals 0 is one of my possibilities. X minus 2 equals 0 is the other one. Solving for x, one of my x's is just 0, and the other one is positive 2. I expect you to set up both equations, and in this case you don't have to show me, but certainly could show me this plus 2 on both sides to get x equals 2. First, get the y by itself, so the first thing I'm going to do is to subtract 5x from both sides. I'm going to put this in blue because this is a part you wouldn't have to show the work for. What I would expect to see, though, work-wise, bare minimum, is in red. So I'd have 2x squared minus 5x equals, now I'm going to replace the y with a 0. In this case, there's an x in both of these again, so factor the x out front. What's left is 2x when I divide this one by x, and a minus 5 when I divide this one by x. The x is out front. If I were to distribute that x back in, I'd end up back where I started. So my two equations, x equals 0, 2x minus 5 equals 0. Well, the x equals 0 is just part of my answer because it's already solved for x. At this point, in blue again is optional work. I would add 5 to both sides. In red is mandatory work, and I'd end up with 2x equals 5. And then I would divide both sides by 2 to solve for x, and my final answer, x would equal 2 1/2. So if I were to graph this parabola, this equation here, I would get a parabola, because it's an x squared, that crossed the x-axis at 0 and at 2.5. Now in this case, the y is already isolated. I look, the coefficient of this x squared is 1, the coefficient here is 10, and the constant is 25. The greatest common factor of that is 1. There's nothing I can factor out of all three of those numbers. There's an x squared here and an x here, but the third thing doesn't have an x at all, so there is no common factor to factor out. At this point, I go to the double parenthesis factoring that we did in the last class. To get the x squared, I would have to have an x and an x. Now, I'm looking for two numbers that multiply to give me positive 25 and add to give me positive 10. I'm not making you on today's assignment list out all of your factor pairs and show your check. However, if it helps you to do this, I'm going to do this in blue. Factor pairs of 25, 1 and 25, negative 1 and negative 25. 2 won't work, 3 won't, 4 won't, but 5 will. 5 times 5, negative 5 times negative 5, and then again, 6 won't, 7 won't, but I've already kind of doubled back because I have 5. I'm looking here for the combination that will add to positive 10, so it's positive 5 and positive 5. I'd end up with x plus 5 times x plus 5. Now, if you wanted to do your check to make sure it worked, the inside part is a plus 5x, the outside part is another plus 5x. When I added those like terms together, that's where that middle term of plus 10x would come from. Because these are both x plus 5, I don't have to solve both of them separately. I could just say, well then, x plus 5 would have to equal 0. So x, I only have a single 0, x is negative 5. And just as a heads up of what that graph would look like then, I would have a parabola where the vertex of the parabola was on the x-axis at -5. That's why it just has a single 0. It just touches the axis at that point, but it doesn't actually cross the axis. There's no common factor here. The y is already by itself. So I'm going to go straight to my double parenthesis factoring. And again, work you don't have to show, but can be helpful. Factor pairs of -42. You had to show this on last night's assignment. 1 and -42, or -1 and +42. 2 goes into 42, so 2 and -21, -2 and +21. 3 goes into 42, so 3 and -14, -3 and +14. 4 doesn't go into 42, 5 doesn't, 6 does. 6 times -7, -6 times +7. Ooh, and I totally forgot. I meant to tell you that this needed to be, and this was my mistake, I forgot, it was a typo that I forgot to fix. It should actually be a plus 42. So that's going to change all of my factor pairs here. I messed up and I wrote that on my note sheet and then I forgot to write it on here. So positive 42 means I've either got two positives or two negatives multiplied together, not a combination of the two. Otherwise, I would have to say this is not factorable. And that's possible, but that was not intended on this. It was just a typo when I typed it. So to get positive 42, it's two positives or two negatives. The combination that will give me the -13 is the x minus 6 and the x minus 7 equals 0 because we're replacing y with 0. So my possibilities, x minus 6 could equal 0, or x minus 7 could equal 0. Adding 6 to both sides here, x equals 6 is one of my zeros. Adding 7 to both sides here, x equals 7 is the other one. So this parabola, when I graphed it, would cross the x-axis at 6 and 7. The first thing I want to do here is to get the y by itself. So x squared minus 3x, and I would subtract 10 from both sides. Again, you can show that work if it helps. Minus 10 here and minus 10 here, which is why this becomes an x squared minus 3x minus 10. Y gets now replaced with 0. To get the x squared, I would have to have an x and the other x. Thinking about the factor pairs of -10. One's positive, one's negative, so 1 and -10 or -1 and +10 wouldn't give me -3. 2 and -5. Hey, plus 2 minus 5. That's going to give me the -10 when I multiply, and the positive 2x minus 5x would give me that -3x. So x plus 2 could equal 0, or x minus 5 could equal 0. Subtracting 2 from both sides here, x equals -2 is one of my zeros. Adding 5 to both sides here, x equals 5, not x plus 5. X equals 5 is the other zero. So if I graphed this parabola, it would cross the x-axis at -2 and at +5.